All right, folks. Here we are with a 4 GB Corona, very likely one of the later versions, V4, V5, V6. The way we can tell that is by looking at the R2C6, R2C7, and the missing R2C10. Now, if this was a 16 megabyte console, we'd need to bridge all three of those, including R2C10. Because it's only a 4 gig console, we don't need to read the NAND via these headers. We were going to read and write the NAND via the 4 gig header, so we only need to bridge the two. So I am wanting to do some validation and experimentation with this Ace V5 chip. So that's what we're going to mod this console with today. As you can see, if you're experienced modder, we've already got a 4 gig header installed in this. That's because this is a follow-up video to just after I shot a video for the 4 gig USB tool. So this header is a header that works with this tool to allow me to read and write that NAND, so it's already pre-installed. So we're going to use this tool to read and write the NAND, but you could just as well use one of the older SD tools, which is the same thing as the USB tool, just you need an external SD card reader writer. And then we're going to use the Ace V5, and then very, very, very likely we're going to need a postfix adapter under here. It's not an absolute guarantee, but most of the time when you're missing R2C6 and 7, you're also going to need a postfix adapter. I'd say better than 90% chance. We will take off the fan and heatsink though, and we'll look for those traces, which are the ultimate proof of whether or not we need a postfix. So the tools, again in summary, that we're kind of using here is some way to read and write. So we're going to use this 4 gig tool. You could alternately use an SD tool. We're going to use a glitch chip, in this case the Ace V5. And we're going to use some flux. We're going to use some tweezers, and and like I said, probably a postfix adapter. So one more tool we'll use will be the fiberglass scratch pin here, and that's actually the process I'm going to start with. So we're going to be soldering to some of these connections for power, ground, and then the E and F points. So I'm going to go ahead and use this scratch pin to remove that top coating. So what I want you to look for here is how these points really just start to shine, meaning that they were coated in a covering, and that covering would have prevented us from being able to solder to them very well. And so you want to stop probably about there. Look at those points as compared to the ones beside it that I didn't do, and you can really see the brightness difference. If I tilt it here, I think you'll get even more of the view different. Yeah, you see how those just really shine, whereas the other ones are very dull. That's because they still have their coating on top of them there. So we're going to reference the installation diagram straight from the manufacturer here. So the x360ace.com, you can get these images, or they're on the product page on weekendmodder.com/store if you order your Ace V5 from us, or even if you just want to visit the site, you can get these same images there. So you can see we've got quite a few connections coming right off that header that we shined up. We've got ground, E and F, power, and then they highlight that you need to bridge the R2C 6 and 7. So we're going to go ahead and start off with tinning those up, getting them ready for connection. So I'm going to apply a liberal amount of flux. There we go. So just some flux across the top, and use my iron and just kind of get a little melty. And then just referencing the install diagram, each of the points that I'm going to eventually connect wires to, I'm going to go ahead and just pre-tin with a ball of solder. The very first one I'm going to do actually here is the ground, and it's this odd guy here in the corner. The reason I'm calling that out is the ground is attached to the wider ground plane here. so it can dissipate more heat than the other points. So be prepared to need to hold your iron on the ground point for longer because it takes more heat to get it up to temperature where the solder can adhere. The other points will not require as long, so don't treat them the same way. So now you can see there's a nice little solder ball on there, and then we know the next two, top and bottom, are our future E and F points. So as you can see, we're just going to move right along, soldering these guys. And don't worry if your solder ball kind of turns that cold and like gray color and doesn't stay super shiny the first time. We're going to reheat these again, so it's not a huge deal as long as the connection is good. So there we go. So now that's our ground, E, F, and then power connections. So the other thing that we need to do right here while we're in that same area is the R2, C6, and 7 bridges. So what that really is about, if you get down real close, like we are now, and we look, the trace, the small little conductor inside the board, runs up through these points, R2, C6, and 7, and connects to E and F here. So if we don't bridge these, there will be no signal reaching E and F. So bridging literally just means connecting these two empty pads. You can see where the ones that kind of look dull have a resistor. They're actually 0 ohm resistors, so that they have no resistance. They're just bridges themselves. So that means what we can do is just span this gap with anything that we can get to do the job. In the past, I've used tiny little bits of wire and done this. You can also just bridge them directly with solder. So that's what I'm going to attempt to do here. Not always successful with this. The primary thing to consider and think about is just don't burn your board up, right? Don't be afraid to back off your heat, clean up your flux, and kind of just start over if you really need to. So I like to rotate the board 90 degrees while I'm doing this so that my iron is kind of like parallel to them. And you can see my flux is kind of over the wrong way, so I'll just drag my iron as I bring it through. So now they're soaked in flux pretty good. And I'm going to see if I can keep you guys real tight down in there while I'm doing this. So I am going to hold my iron so that it's kind of horizontal across the points. And I'm going to continue to kind of dab the solder down on there. And it's not currently adhering at all. You can see that the points are still not connected. So I'm going to try a few more times here. Okay, so there's that one. You can see how now there's a little bridge of solder between those 2 points. So my goal will be to do the next one without touching that first one and breaking the bridge, right? So again, like I said, don't be afraid to back off, take your heat off, give it a rest for a second. There we go. So now we got the second bridge. So that's it. That's all it takes is just we're electrically connecting those 2 pads. We're making them have conductivity through them so that they pass the signal through. But you can notice that R2C10 next to it is still 2 separate little dots that's not bridged. That doesn't matter for our purposes here with a 4 gig. But again, if this was a 16 megabyte Nand Corona, you would want to bridge R2C10 as well. All right, so let's go ahead and get our glitch chip kind of placed here, figure out where we want that to go. And then let's just get her right in there. All right, now according to the ACE site, it doesn't look like I need to do any bridging of the different P switches here, P1, P2, P3. So I'm just going to real quickly tin the pads on the ACE chip. So I'm just comparing these to use. All right. The one thing you might consider is the wires that you use for your power and ground. Could be a little thicker than what you can get away with for the signal wires. So whatever you've got in the 28 to like 30 AWG sort of size. So I'm going to go ahead and solder that wire in there. I'm going to solder this one to the ground. And then the ground was this corner one. So now we can just heat up our solder ball, stick our wire in there, ends up nice and tidy. The power was this guy, and I've got too much exposed wire on the end here, so I'm just going to trim that back. So we're going to go ahead and get the power wire in there. So now we got power to our glitch chip. And then E and F are those other two wires. So go ahead and get that connected too. E is on the top, F is on the bottom. So we'll just connect these like so. E. And F. Got a little bit too much solder on the tip there. I don't want to bridge something. And E and D. Oh, I've been saying F this whole time. I'm going to have to correct myself. Re-record some of this audio maybe. E and D. E and the bottom is D on the ACE V5, not F. All right. So it's important to be constantly referencing the diagrams back. So E and D, I was calling E and F. So, all right, so now we need to get the C1 and C2 connections done, and then we'll do the A and the B for postfix and stuff. So they are that little grouping of resistors down here next to the south bridge. So let me switch. So it's this group right here. So same story with the fiberglass scratch pen. Those resistors have some coating on the contact over them. So you can see these are getting shinier as I run the scratch pen over them. So the C1 and C2 connections are those two lower ones. You can't really focus on those with the scratch pen at least. So I just do the whole area. So now those are more willing to take solder. Drop some flux right up in there. That might even be a little too much. There we go. So the dot in the diagram is between C1 and C2. So electrically speaking, they're a set of resistors. And I don't really have any clue what their value is, but the idea is you could connect to the side of either of them or somehow manage to bridge between them. So there we go. You see how those two are now bridged? That's fine. It just means we got a good amount of solder in there for things to stick to. So this is where I often find it's helpful to use a pair of tweezers to actually hold the wire. so that I can see past my big sausage fingers here. So I'll see if I can try to do this while you guys are so close, but it makes me have to work sideways. Alright, there we go. So I removed the solder bridge, but you can tell that I'm connected to the inside of the resistor there, right? So effectively, it doesn't matter whether I connect to the left side or the right side of this resistor or the left side of that one, right? They're just jumped between them, so that will work just fine. So just to demonstrate with a slightly larger gauge piece of wire, right? Like this one's just a little bit bigger. So what you could kind of angle yourself to do here is come in from the side and tack yourself to the side of that resistor. So let me see if I can pull that off. I'm gonna have to raise this camera just at least a little bit. Still gives you a pretty good view. All right. Okay. Got my. All right, look at that. So this one is connected to the inside, and this one's connected to the inside on the lower one. So we are good to go. We're ready to connect those up to our chip. So we said that top one was C1. So there's C1. We said the bottom one was C2. Alright, we'll just kind of lay that down. Alright. So now what we got left is A and B, and those are going to be our post point and our CPU RST point. So let's get the post out of the way since we've already talked about it. So to really know for sure, or to actually apply the post adapter, we're going to need to take the X clamp off. Strongly recommend the X clamp removal tool. You can do this with a screwdriver or whatever. You just got to be careful. So you can seat this tool in further than you really would want to for using it. If you look at these guys sideways, you can see the ring is fairly shallow. Let me get the camera view here. It's fairly shallow, so you don't need to come in much further than just right there, right? So we're just calling or getting our tool inserted just past there so that as we lift, we're not flexing into the board, right? We don't want to scrape the board. So it's just a matter of using the tool and rotating. Comes right off. Easy peasy. All right. So now the heatsink will come off and slide over. You can just disconnect it, get it out of your way for now. And so the thing we're looking for, and we already knew to expect, is the absence of the traces right here. So again, if you go to weekendmodder.com, you go on the Corona tab under guides, right? Guides, Corona 4 gig. You can see we've got the 4 gig identification. Then we've got this whole thing about the traces. So the traces are these little lines. That's what we would be looking for. If those little lines were present, then we would not need a postfix adapter. We could solder to the pins on the bottom side. If you look at this image, there are no little lines in that area. There's a bunch of them missing. So compare that to what we're looking at here, and sure enough, just as we expected, we got those missing traces, right? We don't have those little lines. There's just missing bulk area here. So we do need a postfix adapter. So let me grab one of those and we'll install it. All right, so I grabbed a postfix V2, and it really doesn't matter if you use a V1 or a V2. The only difference in them is that the V2 has some traces on it that will emulate extending the wire length. And here, let me explain what I mean a little better. So if you get down close, just like we talked about traces on the motherboard, if you look real carefully, you should be able to see there's kind of like horizontal lines going through the postfix adapter. What those are literally just loops of traces that are running back and forth and back and forth and back and forth. And then the pads are at a certain length. So the idea here is this pad is as if you connected a 5 centimeter wire to the post point. This pad is as if you connected a 50 centimeter wire and a 70 and a 90 and a 120. So all of these points provide a post connection, but just at a different simulated wire length. You can also connect like directly to this pad if you're careful to not damage your pin, that sort of thing. So now, I strongly recommend if you're doing a postfix installation that you have a multimeter, and that the multimeter is capable of reading at the 200K setting. So Harbor Freight sells a multimeter that sometimes they even give them away. They're like $5 otherwise. So I suggest setting that to 200K, and we'll use that to validate the installation of our postfix adapter. So what we're looking for is for that little pin to slide under the XC GPU and make contact with one of the little balls that's on the edge. These things have a grid array of balls that make the whole thing like stuck to the board. That's how it's attached. It's called BGA, or ball grid array soldering. And so this is going to go under the chip and make contact with one of those little spots. So it is rather delicate. You want to line it up properly. You make sure your pin's down as much. The little capacitor bank that's right here is going to raise it a little bit at this point. But what we're going to do is just kind of edge it forward, not too aggressively, until it slides down past those, right? And then we kind of want to make sure that we see that our pin is also sliding and going down under, right? And it is like spring loaded. So a reasonable behavior is kind of like you see when I push it in, kind of springs backwards here. And then the idea is that this other side is supposed to be a retaining clip. I've gone as far as hot gluing the edges of these. Sometimes you get a good quality postfix and things just fit together and everything's good. Sometimes these little edges don't want to mate together properly. So don't be too married to the idea that you have to get the clip all the way around the thing like I'm doing here. It may be that you just need to put a piece of tape here, piece of tape there, and then maybe put a little dab of hot glue around, whatever. But in this particular case, this was a good postfix. It's mated nicely. I'm pushing on the board a little bit, and you might be able to see it flex. You don't want to do it too hard, but we should have our postfix in place here. So the measurement that we'll take to validate the postfix would just be from ground to one of the post points. And what we expect to see is a reading somewhere in the like 30 to 50 k ohm sort of range. So if I touch right here, you can see that we've got a 40 k ohm reading, and that makes me believe that we've got a successful postfix installation. As I mentioned before, we could also touch these because they're just runs to that. So if I touch the 5, you get the same reading. If I touch the 50, the 70, same thing here. So that is a successful postfix installation. I would strongly advise at this point in the install, since you've had the CPU off, you have broken the thermal bond that was set up between the heatsink and the XC GPU's like top casing, what they call an IHS or an integrated heatsink. So it's really a good idea to replace that thermal compound. It's just a real basic thermal paste to enhance the conductivity of the thermal heat away from the chip into the heatsink and the fan. If I can find some, I shall do so. So yeah, I think I got a little bit of thermal paste here. So what you can do is literally just use some rubbing alcohol, or in many cases just a little bit of elbow grease. This stuff is rather dry and cakey. I mean, the 360 is, the slim models even are, approaching 10 years old at this point. So it's just a matter of this stuff kind of loses some of its effectivity over time. So you can see how easily that just kind of came off there. And then there's going to be some residue as well on the heatsink side. So we're just going to clean it off in the same fashion. I'm going to scrub that. That copper core is what really helps draw the heat out there. So that's the primary thing I'm concerned about, is getting that copper kind of clean. So now I'm going to open up this little thermal paste tube. One of these at a local store is going to be $5 or something, but you can certainly buy it in bigger bulk than that. And we're just going to go ahead and apply pea-ish size amount there. And what we can do then is take our heatsink. The lead should be facing towards the plug here, right? So there's the fan header. So we can just kind of pick it up, and we're going to mate those pegs back through the holes and just give it a little bit of a work down. And you can pick it up, and we can just see how it's kind of started to spread out already, and we haven't really applied much pressure to it. So I'll get that back down on there. Flip this over. I'm continuing to hold some pressure just to hold it evenly on there. And the X clamps I just put back on by hand, man, so you can feel the little groove in each of the pegs. And so that last one, all three went on by hand, just slotting into the ridge of the peg. And this last one I usually need a little bit of extra help on to bend it outward while I push it down gently. And then what should happen is that the spring tension of this like steel should allow me to push down a little bit, and it should give just a tiny bit as it flexes in that ridge that's on the retaining clip. And so now we've got our postfix exposed, and we've got our CPU re-thermal pasted. So we're ready to go ahead and set that up as point. I'm not even going to pretend. We're going to reference the documentation. So the postfix is B, right? And so this image is of a postfix V1. That implies to me that the length of the wire does not need to be extended. So I'm going to use the 5 pad here. Oh, switch cameras. So I'm going to use that 5 pad rather than worry about using one of the more extended lengths. I can always change it later, and if we come to believe that will help for tuning, we can do that. So there's the wire connected there. Oh, and look, I did what I advised against earlier. I didn't make sure it would fit first. I need a longer one. Here we go. So there's our wire connected there. And then go ahead and connect that, like I said, to B. There we go. So it's a little longer than we need, so I just kind of curved it around for now. We can trim it up if it seems like that will help with anything or let us get more organized later. All right, so the final point that we need is A, which is the RST, the reset signal, I think. And that's on the back side of the board. And so we're actually going to use one of these through holes to pop up. So I'm actually going to connect the wire to the chip first. So I'm going to go ahead and solder this to A. And then I'm going to pop that through one of the holes by the south bridge here. I'm just going to arbitrarily pick that one. Right, so that just allows me to get to the other side of the board with my wire. And so the A that is called for by these install diagrams is the RST point that is just above and to the right of the larger hole where the screw for the casing ends up passing through here. So you can see this little thing in the shape of a 4 as I imagine it, where it's R4P4 and then R4P5 and R4P3. So what we're looking at is the bottom left one there. So R4, whatever that is, P3. Let's turn this so that we're looking at it the same way as the reference image, right? So here's our picture. So we got capacitor here, and then we got capacitor here, resistor, or another capacitor, resistor, and then we got the points. So it's this one in the image. So let's compare that, like side by side here. We'll go to the desktop scene. So you see what I'm looking at here is capacitor here, another capacitor, resistor, and then that little guy right there. So that's why I feel like same count up here. Capacitor, resistor, this guy right there, right? So that's where we're going with it. So we're going to get our wire. So it's coming back to me after 4,000 consoles back in the day why I used that other big hole. Because if you pass the wire through there, then you can hook it around and come back at that spot. Oh, let me show you without my giant meat fingers in the way. So if you hook it around, you can come back at that spot without having to cross a bunch of other stuff. So let's do it that way. Alright, we only just need a little bit of exposed wire on the end. We're going to want some flux, so let me grab from that over squirt from before. Apply some flux to the spot. Alright, and we'll see if we can't kind of pre-tin it a little bit. Alright. So, we got our wire here. There we go. Alright, so there it is. There's the connection. So, we are fully wired up. Our glitch chip is completely installed. Now, I have previously read the NAND on this console. So I have two matching NAND dumps. Again, I made the video about the 4 gig reader writer. I'll either link or maybe even embed that video in here. So that means that I now have the need to write the ECC file, the file that'll help me boot Zell to this console. So I'm going to grab my 4 gig reader writer tool and get this guy connected so that I can write to the NAND. So I'm going to go ahead and plug it into the header here, kind of carefully. And again, if you want some instructions on this, check out that other 4 gig read-write video. And then as covered in that other video, you need to temporarily solder to this side of the crystal to put the chip in read-write mode. So there we go. All right, now I'm ready to apply standby power to my console and then write the ECC file. So we got JRunner. I'm going to load up the NAND reads that I have. So there's the NAND dump 1 and 2. We can do a NAND compare. So I got a NANDs are the same message for the two files that I have. Now I want to select my target dash, and that should let me bring up the 4 gig read write, right? So I went to advanced 4 gig read write, and so what I'm going to do is in my source file now, I'm going to go to my JRunner, common, ECC, and here's what we're looking for. We got a Corona 4 gig ECC, 4 gig ECC for now. Again, we got NAND backups, so we should be fine if we need to rewrite it back to the console. So now I'm going to apply my standby power. So power adapter is plugged in. And then I'm going to connect my USB cable to my 4 gig reader. All right. Now, you're going to see a message from Windows pop up telling you that the disk that you just plugged in needs to be formatted. You really don't want to do that. You don't want to format this thing. We want to read and write from it, that sort of thing, right? So we're going to hit refresh drive list. We've got a physical drive I that we didn't have in there before. We've got our 4 gig ECC loaded up, so we're going to say write. You're about to write to I. Yep, that's what we want to do. So you can see what file writing to from there. It says done. So we can close this, and it's just that quick. I mean, the ECC file is tiny. So we just go ahead and unplug, all right? And then we can disconnect our standby power. And so now we do need to remove our 4 gig reader writer so that we can boot the console. So we got to do a quick little remove of that crystal wire. And then that's why this header is so handy, man. You just get to boop, pop it right off. And now we're ready to boot this console, hopefully receiving our CPU key from it. All right, so what I've got going on here is just the console connected up, powered, network, and video out. The reason I have network connected is because I'm lazy and I don't want to type in the CPU key. I want the Zell to get a network address so that I can just pull the CPU key over the network. So just turn the console on. I see a blinking light on the Ace V5. We got 1 blink, 2 blinks. Let's see. 3 blinks. All right, so now we've got it turning on. So it was 3 cycles to get to Zell. And you can see Zell is starting up. Now, requesting DHCP, that's dynamic host something protocol, dynamic host. Anyway, what it means is it's trying to get an IP address. So I really hope that it succeeds. If you see an IP in .99, then it did not successfully. Yeah, so you can see here we got 1.99. So that's not super fun because that means we need to go ahead and type in the CPU key into JRunner. I don't know why my network cable didn't work there. I know this console has a functional network thing. So what I'll do a lot of times is just take my phone and snap a pic of the CPU key so that I can then, pull it up without the console having to stay running and stuff, so that I can type it into JRunner. So I'm going to disconnect the console from over here, right? Bring it back with me to a main station. And let's get that CPU key entered into JRunner. Our photo here with our CPU key, we can pull up JRunner, and I could just type it in, which, like I said, I'm lazy. I tried to avoid this if I could, but it's 8A6BD57 06697C9866516A367C7C90A B72. So if you typed it in correctly, my load source needs to have my NAND selected, right? And so if you typed it in correctly, you should get CPU key is correct, added key to the database, and then if we close this timing assistant, this NAND info area would have been blank before, but now it's got like our DVD key, it knows our manufacture date, our serial number, we can see our different CB statuses. So we get all that information unlocked by virtue of entering the CPU key here. So that is very cool. We have succeeded in getting our CPU key. So now we can go ahead and create an XE build image. So this will be the actual hacked image that ends up continuously running on our RGH. So we're gonna literally just click that button. It's gonna start and spit out a bunch of stuff. Now I want to make sure we have the right options selected here. I think this is right for an ACE V5. You want glitch 2 and SMC plus, but I'm not positive. We might want this CR4. So we may have to build this image again if it doesn't boot nicely with this one. But what you can see is ultimately what we get is this saved to a folder with the serial number. And then what it creates is this updflash.bin file. It actually loads it up as source for you. So this upd flash is the same thing as like a NAND dump, but it's the modified NAND dump. So that's the thing we now want to write back to our console. So in order to put our console in NAND reading writing mode, we just throw our 4 gig reader writer back on there. And just don't bully this thing. You want it to go on nice and easy like you expect. There you go. See, I was over by 1 on it. Alright, and then again this guy gets connected here, puts it in that mode. And so now grab our standby power, throw that on the console, pull up our USB cable, get the USB cable plugged in. Alright, so we get that same message. You must format the disk drive. We do not want to format the drive, right? But we do want to write to it. So I'm going to go to Advanced, 4 gig read write. We've got our physical drive, the same one that we saw before. We've got our UPD flash as source. So we're going to say write, yes. And so now we get all kinds of blinking on our light. That's an activity LED. and it finishes in 6 or 7 seconds. It says image is ready, so we're good. So we can actually unplug now. We can disconnect our standby power, and then we can remove this reader, hopefully for the last time, depending on if we need to write another 4 gig NAND file to it. Okay, so now we're ready to boot test this guy and see if we can get our full-blown RGH image up and running and booting with us. So I'm going to move over back to the monitor for that. I can't reliably count on HDMI to work, the output capture here, so that's why I end up with just a camera pointed at a screen. It's the only 100% consistent way that I have to capture this. So there's my console. The only thing that's connected is powered video. We got the glitch chip in here. So let me just go ahead and tickle the power button. So we got one quick little beep there, and we're looking for a boot and the ring of light to activate here, and that isn't happening. So I'm thinking that our SMC options for that thing that we picked was probably not right for the glitch chip. The ECCs are more forgiving than the XE build image, so I'm not getting any more blinks, any more activity. I didn't get a boot. My LED didn't come on. Actually, my fan's not even on. That's somewhat concerning. Oh, that's not good. I just didn't have the fan plugged in. Give her another shot here. Alright, so this time I got a longer. Oh, we are continuing to blink this time. So could have just been first plug-in jitters. There we go. We got a ring of light booting. Alright, we just successfully booted our SMC modified RGH console. I'm gonna get my controller synced up to this guy. So it's acting as if it was a brand new console. This is you just bought your Xbox screen, and so we'll go through that, and we'll reboot this guy a couple times and see what our boot time is like. So we're on 17559, which is the newest available dashboard. So let's go ahead and, I meant to say turn off. All right. So now I'm going to see if we can get this where you can see the LED. I'm going to use my wireless controller to turn it on now that I'm synced. So there's one blink, two blinks, three blinks. That's what it took last time. Four blinks, five, six, okay. So 6 blinks to start up, 30, 40 seconds? Not terrible, but not great. Sometimes can impact the performance of the boot time when you put the case back together too. Just different interference and stuff. So let's do this like one more time. And then I'm just curious enough that I think I will change the option, create another NAND, and compare the boot times. So here we go again. Alright, using the wireless controller. One. Okay, that was a first boot. Insta boot, as they say. First glitch. Well, that's somewhat inconsistent, right? But not bad at all. Sub a minute, sub 30 seconds. Average for sure. Let's do one more. All right, here we go. Turned it on with the controller. 1. Okay, 2 insta boots in a row. Seems like success ain't worth messing with, but we'll do it for the education. So let's cut this thing off. So we know we get some pretty decent instant booting out of the current configuration. So here's what I'm going to do. I'm going to take and say show working folder. There's that UPD flash that got generated with our SMC plus setting. So I'm actually going to change its name so that it doesn't get overwritten. I'm going to name it SMC plus. And then what I'm going to do is I'm going to load back up my original NAND dumps. I'm going to change my option to the CR4 option because it says it speeds up glitch timeouts, and this one says it increases the glitch timeout. And so I don't even know what glitch 2M is about. All right, let's go with CR4. We're going to say create exe build image. So now we've got a new UPD flash bin file. You can see it here. That's why I renamed my old one. So this is the new UPD flash built with the CR4 option. So let's put our 4 gig reader writer back in one more time and write that NAND and see how it does. Alright, so I need my standby power. Cuckoo-ca-choo! Alright, we need our USB connection. Alright, there we go. Once again, our best friend Microsoft thinks that we should format our drive, and I'm not going to do that. So, we do have our UPD flash loaded. I am going to write, we're going to override it, and we get all the blinky telling us we're writing, and we have successfully written. So now we're ready to unhook our standby power, unhook our USB, and once again remove our programmer. So there's that crystal line disconnected, pulling off the header, and let's go back to boot testing. Alright, so once again we'll hook up power and video. And so I think the wireless syncing is independent of the NAND, but I'm not positive. So let's see if my controller still cuts it on. There's one blink. Ooh, first boot instant. All right, so it works with either option, that's for sure. But that one didn't have a slow boot to start with like the other one did. I mean, it could just be that the console's warmed up. Oh, I gotta go through this setup again. Brand new NAND. Detecting console connection. Alright, go play. Alright, so let's turn it off and give this guy a couple of boot tests so he gets a fair shake. Alright, he's off. Turn him back on. 1, 2. Okay, so we're not going to always instant boot. 3, 4. Ooh. Oh, there was a 4. The other one had some 4s though, and then it did like, what was it, 3 instant boots in a row? So I don't know. I don't know which one's going to turn out to be better. Alright. Here we go. Turn it on. 1. Ooh, another instant boot. So far, I'm going to say this option's better. They're more consistent, but we've only done half as many tests. I think we did 4 with the other one. So let's do 4 with this one. Alright, here we go. So we did a instant, then 4, an instant. That was just 1. Now 2, 3, 4. Gonna go at 4. Seems like it's either 1 or 4. Haven't had any in betweens with this option. Alright, let's do one more. 1, 2, 3, 4. Man, if it's gonna go either for sure at 1 or 4, that seems pretty darn acceptable. 4 is like 20, 25 seconds, and 1 is obviously immediate. So I'm going to say play with both because it could vary by your console, but I'm going to leave this one with the CR4 selection on the reset. Seems like that is the thing to do here with this particular one. So there it is, an Ace V5, very quickly booting a Corona V4, V5, something like that. It really doesn't matter, is my argument. Cleaning up a little bit of solder here. The only other thing I would do with this console is if I was going to ship it, I'm going to put a little bit of hot glue just to hold these wires down, and then especially to hold this postfix a little bit, because if you look at that, and I don't know if you guys can see it as well, but if I do that, it flexes just slightly, and any sort of movement like that, the postal system is just going to wreck this thing, right? So we'll go ahead and just get us a little dab here and a dab there, just to hold it in position, keep it from doing any moving, and then maybe to hold these guys down. So there it is. This console is now RGH modified, and hope you enjoyed watching. Thanks.